Charles Hyland. I'm here today to talk to you about organic fertilizer, biochar, and sustainability generally and in specific examples. I'd like to pass around a couple visual aids to start with. In one bottle, there's black material, which is biochar, and in the other bottle, there's a gray material, kind of tannish, which is the trace element, full spectrum fertilizer from Pacific Biofert. And if you look closely at the bottle of Biofert, you can see little black specks in it, and that's biochar. That was, in large part, my doing. The other ingredients, primarily phosphate rock and things like that. The biochar makes up a small percentage of it, but a crucial one. First, I'll just introduce myself a little more besides my name. I moved to New Zealand in 2012 to pursue a PhD at the University of Auckland. And before that, I worked for over 10 years at Cornell University in the US as a research scientist. For 8 of those years, I worked in a soil biogeochemistry laboratory. And that biogeochemistry is just a big word for the study of how things flow in and out of agricultural systems. So fertilizers, carbon, pesticides, all these things are the concern of biogeochemists. But a lot of focus on nitrogen and phosphorus in soil and in water, and how things move from the soil on the farm to the water downstream, and what factors control those. After doing that for a little over 8 years, I really liked it, but I had the opportunity to move one floor down and work as a soil microbial ecologist in a soil microbiology laboratory, where we did work. The lab did a lot of different kinds of work. My projects focused on optimizing commercial compost operations and doing lab and field research using different composts and different biochars, and seeing how they affect nutrient leaching and how they affect the respiration of soil microbes. And respiration of soil microbes is just a measurement of how microbes how lively they are. It's literally measuring their breath and their flatulence in a closed jar with chemical absorbance. But it allows us, by doing that kind of work, to see what makes the best kind of compost. What do the microbes actually like the best? Not just anecdotally, like what does someone feel better about putting in there, but I'm a diehard organic person. I come from an organic farming background. My grandmother had bought the very first edition of the Encyclopedia of Organic Gardening from Rodale Press, 1953. She gave it to me when I went to university, and I'm all about organics, but I'm definitely logically rooted in science, and so I respect everybody's opinion, but in case you hear me say something that you may not agree with, that's just my opinion based on my experiences and my readings. So after I finished my master's at Cornell, I worked there for another year in the soil microbial ecology lab, and then I started consulting for companies that were looking to improve their environmental footprint, and I was interested in getting a PhD and ended up here. Found out that I like working more than studying. After 4 years of a PhD, I decided to go to work, and I got to know Bill Sinclair, whose family owns Pacific Biofert, as part of my university research, and we hit it off really well, and so he hired me, and I worked for him for worked for the company for 3 years, assessing how all of their biofertilizers work, assessing every ingredient individually, and going through stack, like boxes, papers this tall, that were written by the founder of the company, Clive Sinclair, Bill's father, who was quite possibly the most gifted, self-taught scientist I've ever come across. Like through reading his papers, he put people I know in academia to shame in terms of like the quality of the work. So I worked for the organic fertilizer company, but because this is wonderful New Zealand, where I don't have to work in just one place to get health care, I can work on all sorts of things. I've also worked in a consulting capacity in various capacities with different startup companies, one of which is a company that puts hard numbers on farms' environmental footprints. And that's a lot of the freshwater work that I do now is measuring the impact of farm operations on the fresh water that flows through their farms.
The farmers must love you.
They pay us handsomely to do it. And it's, I mean, and really, like, you know, having grown up on a farm where, like, you know, I'm not going to say we had no impact, you know, we burned diesel in the tractor, and, I mean, we had an environmental impact for sure. But there are farmers who you know, try within reason to minimize their environmental impact, and then there are other farmers who that doesn't seem to register with, who, you know, apply, like in New York, where our farm was, the most obvious example is people who spread manure and effluent on top of snow and frozen ground in the winter. Big no-no, because as soon as that snow melts, it's just straight into the river. Like there's almost none of it actually gets on the soil. But it was a major problem, and it was something I actually worked with before I started at Cornell in 2002. From 2000 to 2002, I worked with the USDA as an intern. But I was the only intern, so I got to do lots of cool stuff, mainly going around to different area farms and assessing their environmental impact and ranking the farms basically in terms of which farms are most in need of government subsidies to build things like manure containment facilities and, you know, or put in, you know, buffer strips along waterways. Helping to decide which farmers got enormous subsidies to do those things that are for the common good. And yeah, that's probably the most striking difference I've seen between the agricultural system in the U.S. and the agricultural system here is we have this thing in the U.S. that Cornell is part of, but every state in the U.S. has it, called cooperative extension. And it's basically a land-grant agriculture university. Is the impartial voice of reason on agricultural issues. So they provide lots and lots of like educational materials for farmers, field days about, you know, techniques and equipment, and none of it is aimed at selling anything or profiting in any way. Additionally, cooperative extension does almost all of the soil testing for each state. Farmers send their samples to a state soil lab that tests the soil, provides fertilizer recommendations independently because they're not connected to any companies, and the farmer gets those results back and then decides where they want to buy their fertilizer, and they already know how much. Whereas the system here is, in my opinion, a little more. It's not as objective when most farmers have the fertilizer company handling their soil testing and telling them what kind of testing they need. That just invites self-interest to come into the situation. Scientific information should be objective. It's the root of a lot of the issues that are facing New Zealand related to agriculture, the waterways, climate change, carbon content of soils, that sort of thing. What I do is I produce environmentally sustainable fertilizers and biochar products through my own company, which I've just started, which is the Prt01 Biochar Company, and through my work with Pacific Biofert, that's still ongoing. And I consult on a real wide variety of agricultural and environmental projects.